Good morning, student. As we were doing exercise 1.4, so we are solving next questions. Now I am going to solve question number 10. The question number 10 is same as question 9. The questions are same, but in this question we have to show that these operations are having identity elements. We have to show whether they are having identity element or not. This is our question 10. So the first part of this question is as it was in question 9. The first part is A star B is defined here as A minus B for every A and B belonging to Q. This is the definition of binary operation. Now we have to show that whether it has identity element or not. For this you should know what is an identity element. An identity element, if binary operation is defined on A cross A to A Cartesian A to set A, then an element E belonging to A is said to be an identity element of this binary operation if and only if E star A is equal to A star E, and that is equal to A for every A belonging to capital A. This is the definition of identity element as I have already taught you. So this property of identity element we are going to use in these questions. For solving first part, let E be the identity element in Q because our binary operations are defined on set Q. Therefore, we have to take identity element in set Q. So therefore, A star E will be equal to A is equal to E star A. And what is the definition of A star B? A star B is A minus B. Therefore, A star E will be A minus E is equal to A, and E star A will be E minus A for every A belonging to capital Q. And we will find out the value of E by equating first two. We will see that the value of E is A. We will take E to the right hand side and this A will go to left. A minus A 0 and E value of E will be 0. And on equating second and third, we will see E is equal to A plus A. The value of E is 2A for every A belonging to Q. It means this implies E is 0 and E is 2A. E are having both values 0 and 2A, which is not possible. Simultaneously, E cannot take both the values. Therefore, identity element does not exist. Identity element E does not exist for this binary for star in Q, for this binary in Q. Similarly, second part is here binary is defined as A star B is equal to A square plus B square for every A and B belonging to Q. The questions are same as in question number 9. Here we have to show only the identity element, whether it has or not. So we are supposing E be the identity element in Q. Then by the definition of identity element, this implies A star E will be equal to A. That will be equal to E star A. On changing the order, A star E and E star A both will be equal to A. And what is A star E? A star E by the definition of A star B is A square plus E square. And E star A will be E square plus A square. And A square plus E square is same as E square plus A square. And we will have to find the value of E square. From on equating first and second and third, we will find the same value of E square. And that is A minus a square, under root of plus minus under root of a minus a square. And you will see here, we will see whether it belongs to set Q or not. For example, putting a is equal to 3, 5, 4, you can put any number. We will see that on putting, for example, a is equal to 5. What will be e? E will be 5 minus 5 square. That is minus 20, under root of minus 20. That is imaginary number that does not belongs to Q. So therefore, here also identity element does not exist for this binary operation. Second, part third. A star B is defined as A plus AB for every A and B belonging to Q. Let E be the identity element of this binary operation in Q. Then A star E will be equal to A, and that will be equal to E star A. And on applying the definition of binary operation in this part, A star B is A plus AB. So therefore, A star E will be A plus AE, product of the elements. That is equal to A is equal to E plus, now the first element is E. Then it will become E plus AE. On equating first two, we will get AE, A minus A, 0. And on equating second and third, we will get A is equal to AE plus E, and taking E common, value of E is A upon 1 plus A. So we are getting the value of E 0 and A upon 1 plus A, which is not possible for every A belonging to Q. You cannot have two values. Hence, there is no identity element for this binary operation also. Question number 4, part 4. Here A star B is defined as A minus whole square of A minus B for every A and B belonging to Q, and let E be the identity element. As we know, what is the by the property of identity element, A star E will be equal to A and E star A will also be equal to A. And what is A star E? A star E is A minus E, whole square of A minus E. That is equal to A is equal to E whole square of E minus A. On solving the value of these equations, value of E, we are getting value of E, A, on calculating the value, E is equal to A minus plus under root A. And here on equating second and third part, E is equal to A plus minus under root A. You can calculate it by keeping E on the left hand side and the terms without E. We will take them to the right hand side and then we will find the value of E. And E, we are getting A minus plus under root A and A plus minus under root A. So they are different values. It means there is no identity element for non-zero elements, rational numbers, because this both equations satisfies only for 0. If we take A is equal to 0, then we will get the value of E 0, and here will we also we get 0. So these both equations satisfies only for A is equal to 0, not for any non-zero rational number. Therefore, there is no identity element. We have identity element is for every A belonging to rational numbers. This equation satisfies only for A is equal to 0. Therefore, there is no identity element for non-zero elements, rational numbers. Fifth part. Here A star B, A binary B is AB upon 4. And let E be the identity element. And by the definition of identity element, A star E is equal to E star A, and they both are equal to A for every A belonging to Q, rational number, for every rational numbers. And A star E is AE upon 4. E star A is EA upon 4 is equal to A. AE and EA are same, and by solving these equation, the value of AE is equal to 4A and E will be equal to 4. And here we are getting an identity element. For E is equal to 4, it satisfies this property of identity element for every A belonging to rational numbers. Here E is equal to 4. 4 is the identity element of this binary operation in Q. So this is the only part of question 10 which is having identity element. Sixth part, A star B is defined as AB square, and let E be the identity element, and this implies A star E will be equal to A, that will be equal to E star A, and by the definition A star E is AE square, A into square of second number. Here second number is E. AE square will be equal to A, that will be equal to EA square. On solving first two, we will get the value of E square A upon A, that is 1, and value of E we will get plus minus 1. And on equating second and third, A is equal to EA square and E is equal to A upon A square, that is 1 upon A. Here also we are getting two values of E simultaneously, E plus minus 1 and E is equal to 1 upon A, which is not possible. Therefore, this binary operation in Q also have no identity element. Now we will move to question number 11. In question 11, A is Cartesian product of n and n set of natural numbers. It means in A the elements are in ordered pairs. On this set A, a binary operation is defined by A ordered pair AB, binary ordered pair CD is equal to sum of the first elements of the ordered pairs. Here first element is A and here first element is C, A plus C, comma, second element of first order pair plus second element of second order pair. So here A comma B binary C comma D is equal to A plus C comma B plus D. In this way the binary operation is defined. We have to show whether this binary operation is commutative and associated, and if find identity element for this binary on A if any. So we will solve. Here I am taking three ordered pairs because here A is equal to n Cartesian n. It means the elements in A will be in ordered pairs. First, in the previous sums we have taken elements, single elements, but here the elements are in form of ordered pairs. So on applying binary on these two elements, ordered pair A comma B star C comma D is equal to sum of the first entries in the ordered pair A plus C comma B plus D, second elements of the ordered pair. A plus C can be written as C plus A, B plus D can be written as D plus B, and it is the definition of the order will be reversed, C D binary A B. Therefore this binary operation is commutative. Next now we have to show associative. So we will take three ordered pairs. Three elements are taken, but these elements are in form of ordered pairs. On applying binary on first two ordered pairs, we will get A plus C comma B plus D star E F. Now we will apply on these two ordered pairs the binary, and it will become A plus C plus E comma B plus D plus F, and it can be written as in brackets A plus C can be written as A plus bracket C plus C comma B plus, last two we are taking in bracket, and this is the definition of A B binary C plus E comma D plus F, and A ordered pair AB star, and this is the definition of CD star EF, and it is associative also. Identity element we have to find. So let XY be the identity element. This implies this is the element of A set A, which is n Cartesian n. So for any element AB belonging to n Cartesian n, binary XY will be equal to ordered pair AB, because this is the identity element. We are taking that it is identity element. We will see whether it exists or not. So on applying binary on these two ordered pair, we will get A plus X comma B plus Y ordered pair will be equal to ordered pair AB, and similarly same by reversing the order, XY star AB will also be equal to AB ordered pair. X plus A comma Y plus B, two ordered pairs are said to be equal if their corresponding elements are equal. This implies A plus X is equal to A and B plus Y is equal to B. On solving, we will get the value of X 0 and Y is 0. Here also we will get X 0 and Y 0. It means the ordered pair is 0 0. But 0 does not belongs to n set of natural numbers. So therefore there does not exist any ordered pair X comma Y such that A comma B binary X comma Y is equal to AB. There is no identity element for this binary operation in n cross n. Question number 12. Here we are given statements. We have to show, justify whether they are true or false. Our first statement is, for an arbitrary binary operation star on set n, A star A is equal to A for every A and B belonging to n. It is not true for every binary operation. If the binary operation is A star A is defined as A plus A, then it will be 2A. It will be not equal to A. It will be 2A. If we will define A star A as A into A, then it will be A square, not equal to A. So this statement is false. It is not true. There are many examples which you can show that A star A is not equal to A for every natural number. It can be equal to 2A. It can be equal to A square. Okay. So second statement is, if star is a binary operation, is a commutative binary operation on n, then A binary B binary C is equal to C star B star A. So we have to show whether these both sides are equal. Is it true? So let us see. We are given that this binary operation is commutative. On applying commutative on this bracket, on these two, first element is A and our second element is in this bracket. So we will write it as B star C star A. We are applying commutative property on these two elements. First element A and second is B star C in bracket. So the order will be reversed. It is given that this binary is commutative, and then we will apply the commutative property in this bracket. It will become C star B star A. So these both, this statement is true. They are equal. Here order is not changed. A star B star C, the order is reversed. C star B star A. It is true. This statement is true. In question number 13, it is multiple choice MCQ. We are given a binary operation A star B, that is equal to AQ plus BQ. We have to choose the correct answer. First option is X is both associative and commutative. So let us see. By the definition, you can see that A star B is AQ plus BQ, and AQ plus BQ is same as BQ plus AQ, that is equal to B star A. It is commutative. Now we have to see associative property. A star B star C. A star B is A cube plus B cube star C. And now cube of first element plus cube of second element, whole cube of A cube plus B cube plus C cube. And what will be A star B star C? A star B star C is B cube plus C cube. First element now here is A and second is B cube plus C cube. It will become A cube plus whole cube of B cube plus C cube. So they are not equal. Here the whole, in this there is whole cube of A cube plus B cube. Here there is whole cube of B cube plus C cube. So they are not same. It is not associative. So it is commutative but not associative. Our answer is B. And in this way this exercise has been completed. So do yourself. And next we will do miscellaneous. Try to solve as many questions you can solve at your own. If you have any problems, you can share with me. Thank you.